video, I'm going to be talking you through the answers to the Edexcel IGCSE higher paper from the 3rd of November 2020. But please note, it's the R paper. It's the paper that was sat in the regions, so it was not sat in the UK. Question 1. Now, in these show that questions with fractions, you've got to be very careful to show every step, really clearly show your workings, because obviously you know what the answer is. So I've taken my left-hand side, and the first thing I've done, I've gone and changed this mixed number 3 3/4 into an improper fraction, a top-heavy fraction. So make sure you know how to convert 3 3/4 into 15/4. Okay, so obviously we're dealing with quarters. So there's 4 quarters in a whole. We've got 3 wholes, 3 fours are 12. Add on the 3 other bits, that gives us 15/4. Now, how do you multiply fractions? It's top times top and bottom times bottom. So you could have done 15 times 7 and 4 times 9 and simplify later, but you can just cancel at this stage. Both 15 and 9 are divisible by 3, so I've divided both numerator and denominator by 3 at this point. And then I've done top times top, bottom times bottom. 5 sevens are 35, 4 threes are 12. And then finally, converting that back into a mixed number where we can get 2 wholes out of this, using up 24 parts, leaving us with 11 left over. So that's 2 and 11/12. Question 2. So we're being asked to construct the angle bisector ABC, which means we've got to halve the angle. We've got to draw in this final answer, the black bit, which is splitting the angle ABC in half. So the first thing we would do is what I've done here in purple. You put the pin of your compass here, the pencil here, or around here, and you just do a little arc. Now, it doesn't matter how big it is, but because it's a consistent arc, that distance from here to here and here to here would be the same. That's the key bit. So the whole point of step 1 is to establish these 2 points, which I've marked with an X. Now, secondly, we're going to do 2 more arcs with our compass, where we're going to put our pin here to start with on the compass, and secondly here. Now, make this a bigger arc, okay? So it's sort of about this sort of length, okay? So it doesn't matter how long it is, but you've just got to make both these arcs the same length. So putting the pin here, I've gone and done this arc here, which is number 2 in red. Then moving the pin over here, I've done the arc here, arc number 3, and where these 2 arcs cross is the key point. You then get out your ruler, which you're just using as a straight line. You're not measuring anything, and you draw a line from here through here with your ruler, and line 4 is your final answer. But it does say you must show all your construction lines, so you do have to leave in these arcs 1, 2, and 3. Question 3. So part A is just the index, one of the index laws. When you multiply, you add the powers. 7 add 2 is 9. Now, for part B, the key bit here is to protect the minors. But by that I mean, when you pop this into your calculator, make sure you put -5 within a bracket. And you can just put this bit here straight into your calculator. So open bracket, -5, close bracket, squared, -4, open bracket, -5, close bracket, and press equals. It will take you straight to the final answer. Now, but why is this the case? Well, -5 squared is -5 times -5, which is plus 25. If you just did -5 squared on your calculator without the brackets, it gives you -25, which is not right. You do need to make sure if you're squaring a minus, you put the minus in a bracket. So -5 squared, -5 times -5 is plus 25. -4 times -5 is plus 20. 25 add 20 is your 45. Now with part C, step 1, you want to undo this fraction. How do you undo a dividing by 4? You're going to multiply both sides by 4. So multiplying the left-hand side by 4, we get 5x minus 3. And multiplying the right-hand side by 4, 4 lots of 2x is 8x. 4 lots of 3 is 12. So let's now go and take all our x's to the biggest side, which is the right. So let's take away 5x from both sides, giving us -3 equals 3x plus 12, which I've carried over here. So I've got all my x's on the right. Now let's get all our normal numbers on the left. How do we undo a plus 12? We're going to subtract 12 from both sides. So -15 equals 3x. Now 3x means x times 3. How do we undo timesing by 3? We divide by 3. So x is minus 15 being divided by 3, which is minus 5. Question 4, part A, write down the modal class interval. Now modal means most, so what happened most often? Well, of these 60 students, something happened 25 times. So what happened 25 times? The length of time it took them to travel to school was between 30 and 40 minutes. So this is your final answer. So just copy that down exactly. So there we go. Now, for part B, work out an estimate for the mean length of time taken. Now, the problem we have here is we know 4 students took between 0 and 10 minutes, or 10 students took between 10 and 20 minutes to get to school, but we don't know exactly how long they took. I mean, these 4 students could have taken a minute, they could have taken 9 minutes, 8 minutes, who knows? So the best we can do is take an estimate, hence why we're estimating the mean. So we go straight down the middle, we take the midpoint. What's halfway between 0 and 10? That's 5. Halfway between 10 and 20? That's 15, and so on. So from now onwards, we're going to assume those 4 students took exactly 5 minutes to get to school, or those 10 students took exactly 15 minutes to get to school, and so on. So we're now going to add up the total of number of minutes taken by the 60 students. So 4 students taking 5 minutes, 4 5s are 20. 10 students taking 15 minutes, well, that's 150 minutes, and so on. So we do this cross multiplying, 15 times 25, 25 times 35, 6 times 45, giving us this number of minutes. Add up those minutes, we get 1,690 minutes. Now that's the total number of minutes taken by all 60 students. So to estimate the mean, we divide this 1690 by 60, giving us 28.166 ... So round, giving your answer to 1 decimal place, that's 28.2. Now be careful, it does ask for an estimate, but don't be tempted to go and round this to like 28 minutes or 30 minutes. This estimating is because of this assumption we made right at the beginning. Okay, when we assume these 4 students took between 0 and 10 minutes, we assume they took exactly 5 minutes, which is obviously just an estimate. So do not go and round your final answer. Question 5. Now, to work out a percentage increase, it's the difference divided by the original amount times 100%. So the difference is 8265 take away 7,500, 765. Divide this by the original amount, so the population of the village in 2017, 7,500. Multiply that by 100%, we get 10.2%. 5b. Now, for these percentage increase or decrease questions, I think it's quite nice just to set it out like this in the 3 columns. So we're going to have our original price, the change in price, and our final price. And we're going to do a percentage line. So always just put 100 in here to start with. So it's 100% to start with. Now, we're told on this occasion that normal prices are reduced by 30%. So 30%, 30 out of 100. So we're going to take away 30. 100 take away 30 gives us 70. Now you then want to think, what is your multiplier? What would you multiply 100 by to get to 70? Well, that's 0.7. I've just done 70 divided by 100. So if the question is phrased such that I'm going from my original price to my final price, I would multiply by 0.7. But on this occasion, we're told the sale price was 31.5 euros. That's the final price after the price change. So you slot the 31.50 euros into your final column, and we're trying to work out the original price. So we're going from right to left. So we don't multiply by 0.7, we divide by 0.7. And 31.50 divided by 0.7 is 45. Question 6. Now, to work out the midpoint of coordinates, you average the x coordinates and you average the y coordinates. Now, how do you work out an average of 2 numbers? You add them together and you divide by 2. So let's start off with the x coordinates, which are -3 and 47. So to average those, add them together, divide by 2, and that gives us the midpoint, which is a. So we sort of set up an equation here which we can solve. So let's solve it. Multiply both sides by 2. -3 at 47 is 44. Divide by 2, we've got a being 22. Now, moving over to the y coordinates, The average of 11 and B is minus 19. So the average of 11 and B. So the average, so 11 plus B divided by 2. When we average 11 and B, we get minus 19. So here's a second equation we've constructed, which we can now solve. So multiply both sides by 2, take away 11 from both sides, we get B being minus 49. Question 7. Now, I know some people teach speed, distance, time as being that pyramid, that triangle thing, but I think it's much easier just to think of speed as a proportion type of question. So we're told here for Pedro that his average speed is 90 kilometers per hour. Now, all that means, what is his speed? It's telling you the distance you travel over a period of time. So Pedro would go 90 kilometers in an hour. He would go 90 kilometers in 60 minutes. So how far would he go in 2 hours 42 minutes? Now 2 hours and 42 minutes, 2 lots of 60 add 42 is 162. So we want to see how far he would go in 162 minutes. So proportionally, how do we get from 60 minutes to 162 minutes? So on your calculator, do 162 divided by 60, and we can see that's 2.7 times as much. So in 2.7 times as much time, he would go 2.7 times as far. So we're going to do 90 times 2.7. So we can see that Pedro in 2 hours 42 minutes would travel 243 kilometres. Now, Jameen is travelling the same distance, 243 kilometres. The journey took her 3 hours, so speed is distance over time. 243 divided by 3 gives us 81 kilometres per hour. Question 8. Now, there's a quick way to do these compound interest type questions. So you start off with your principal value, 1,200. That's what Harold bought the antique clock for. Now, because the prices are increasing by 8% per year, your multiplier is 1.08. Had it been 5% per year, it would be 1.05 and so on. So our multiplier is 1.08. Then our power is the number of years, which is 3. So you can just simply put this into your calculator, giving you this. So to the nearest pound, your answer is 1512. Question 9. Well, we're told that pressure equals force over area. Now we're being asked to work out the force, so we need to rearrange this to make force the subject. How do you undo dividing by A? You multiply by A, so force equals pressure times area. Now we're told that the pressure is 34.8. Now the area of a box with the contact with the table is going to be just obviously the surface area, the square on the bottom of that box. The square has sides of 1.5. So how do you work out the area of a square? It's just base times height. So 1.5 times 1.5. So popping that into our calculator, we get 78.3 newtons. This was straightforward. You didn't have to fiddle around with the units, which you sometimes have to do. We're dealing with newtons here, meters here. So there was no need to change any units. Question 10. So we've just got to work our way through all this information. So the first thing we're told is the number of chocolate cakes, number of lemon cakes to the number of fruit cakes is 3 to 2 to 5. And that's for so I've chocolate, lemon and fruit, C, L and F. So how many shares is that in total? 3 add 2 add 5 is 10. So 10 shares in total, but we're told there are 80 cakes in total. So pop 80 into the total column. And we can see to get from the shares row to the actual number of cakes row, we are multiplying by 8. So multiply each of these by 8, 3 8s, 2 8s, and 5 8s, we get 24, 16, and 40. So that's the number of chocolate cakes, 24, 16 lemon cakes, 40 fruit cakes. Now, starting off with the chocolate cakes, the 24 of them, we sell all of these, so all 24 are sold, and the profit per cake is £2. 24 times 2 is 48. Now, moving on to the 16 lemon cakes, we sell 3/4 of those, so multiply it by 3/4, and the profit for each of those is £1.70. Pop that into your calculator, you get £20.40. Then moving lastly onto the fruit cakes, of which we've got 40. We sell 7/8 of these, so multiply it by 7/8, and the profit for each of these is £2.40. Pop that into your calculator, you get £84. Add these three together, you get £152.40. Question 11. Now the cumulative frequency is the running total of frequency. So between 0 and 20, obviously between 0 and 20 is the 9. Now between 0 and 30 is going to be all the ones from 0 to 20 as well as the ones between 20 and 30. So that's the 9 plus the 19, giving us 28. And then similarly, the third row, the ones between 0 and 40 are the ones between 0 and 20, 20 and 30, 30 and 40. So it's the running total of the top three frequencies, then the running total of the top four, and so on. So that gives us the cumulative frequency. Now, when we plot the cumulative frequency table, it's the upper bound and the cumulative frequency. So the upper bound and the cumulative frequency. So we plot 29, 30, 28, and so on, which is I've plotted here in black. Excuse the wobbly line. It's difficult doing this on my software at home. That should be a nice gentle curve. And then it's optional, really, that red bit going from 0 to 20. So it's a nice gentle curve where you've plotted the upper bound of years and the cumulative frequency. Now for part C, use your graph to find an estimate for the median age. Now median means middle. Now we've got 80 people here, so the middle person is the 40th person. So go along 40, a nice horizontal line with a ruler, then go down and take a reading. Now for my curve, I got 36, but obviously everybody's curve's going to be slightly different as this is done by freehand. So the mark scheme actually allowed any answer between 35 and 38, providing it tied in with your diagram. Question 12. Now, in order to eliminate either x or y, we're going to have to line up the x's or line up the y's. So we need the same number of x's or the same number of y's. Now, I'm going to choose to line up my x's. Now, to do that, I'm going to take equation 1 and multiply everything by 3. That would give me 21x. And I'm going to take equation 2 and multiply everything by 7, also giving me 21x. So taking equation 1 and multiplying it by 3, 3 lots of 7x is 21x, 3 lots of 2y is 6y, 3 lots of 5.5 is 16.5. Then moving on to equation 2 and multiplying everything by 7, 7 lots of 3x is 21x, 7 lots of minus 5y minus 35y, 7 lots of 17, 119. So I've now got the same number of x's. Now I want to either add these two equations together or subtract them in order to eliminate the x's. Now obviously if I was to add these equations together, 21x and 21x would be 42x, so it hasn't been eliminated, so that won't do. So I'm going to subtract the second equation from the top equation. So 21x take away 21x is nothing. That was my whole purpose. 6y minus 35y. So we're minusing a minus, which becomes a plus, gives us 41y. And 16.5 minus 119 is minus 102.5. So here I in purple, 41y equals minus 102.5. So to solve that, divide both sides by 41, and I get y being minus 2.5. Right, secondly, I now need to work out what x is. So go and take one of the original equations. Doesn't matter which one, I've chosen to take equation 1, which I've written down here. Now I've just worked out that y is minus 2.5, so I can replace the y with minus 2.5. Now 2 lots of minus 2.5 is minus 5. Add 5 to both sides, 7x equals 10.5. Divide by 7, I get x being 1.5. Question 13, part A. So to differentiate, to find dy dx for each term, step 1 you multiply by the current power, and step 2 you reduce the power by 1. So 5x cubed becomes 15x squared, minus x squared becomes minus 2x, minus 6x becomes minus 6, and the plus 4 disappears. Now, the differential allows you to work out the gradient for any value of x. But equally, if we know what we want the gradient to be, we can set the differential to being equal to this gradient and work out which x values give you this gradient. So we're going to set 15x squared minus 2x minus 6 to being equal to the required gradient of 2, and then we're going to solve this to find the appropriate values for x. So in order to make it be equal to 0, so we can solve it, I've subtracted 2 from both sides. So I've now got this quadratic equation to solve where the coefficient of x squared isn't 1. So some people will just do this by trial and error, by inspection. I've got a longer way to do this. So to start off with, I need two magic numbers that multiply to be the 15 times the minus 8, which is minus 120, but also add to be the coefficient of x, which is the minus 2. So here I'm posing that problem. What two numbers multiply to be minus 120, but add to be minus 2? Well, that's 10 and minus 12. So my next step is to go from having these 3 terms to 4 terms. I'm basically splitting this minus 2x into 2, being 10x and minus 12x. Now it doesn't matter which way round, so I've gone plus 10x and minus 12x. So at this point I seem to have complicated things. I've gone from 3 terms to 4 terms. Next step, fully factorise terms 1 and 2. So that gives me 5x, 3x plus 2. And fully factorise terms 3 and 4. That's minus 4, 3x plus 2. Now you just need to be a bit careful with this bit of factorising, but you just have got to fiddle around with the sign here perhaps in order to make sure you get the repeated bracket. So my final pair of brackets are the two components that are not in a bracket. So that's the 5x minus 4. And the second bracket is the repeated bracket, the 3x plus 2. So this is factorising this quadratic. Now my two roots are which values for x in turn makes each of these brackets 0. So solving 5x minus 4 equaling 0, that gives me x equaling 4 over 5. And solving 3x plus 2 being 0, that gives me minus 2 over 3. Question 14. So you're just going to start off by multiplying out two of the brackets. Doesn't matter which two. So I'm going to leave the 4x plus 1 alone and multiply bracket 2 by bracket 3. So I've got my for clause. I'm going to do x times 5x, x times plus 6, minus 3 times 5x, and minus 3 times 6. So x times 5x is 5x squared. X times plus 6 is plus 6x. Minus 3 times 5x is minus 15x, and minus 3 times plus 6 is minus 18. Then next step, go and gather together these two middle terms. 6x minus 15x is minus 9x. And then third, my next step, I'm going to now multiply this bracket by this bracket, giving me 6 clause. So 4x times 5x squared, 4x times minus 9x, 4x times minus 18. Then moving on to the plus 1, one lot of 5x squared, one lot of minus 9x, one lot of minus 18. So doing those 6 clause, 4x times 5x squared is 20x cubed, 4x times minus 9x is minus 36x squared, 4x times minus 18 minus 72x. Then moving on to the plus 1, well, I just get a 5x squared and minus 9x and then minus 18. And then finally, gather like terms. So I've got my 20x cubed. My x squareds are the minus 36 and the plus 5. That's minus 31x squared. Gathering up my normal x's, that's minus 72 minus 9, give me minus 81x, and my minus 18. Question 15. So the first thing I've done is this bit in purple, that this angle here, angle from B to D to F, is 70 degrees, being the alternate segment theorem. That's just one of the circle theories you need to learn, that this angle is equal to this angle. Now secondly, now looking at this cyclic quad, going from E to D to B to F. So remember that's a quadrilateral, a four-sided shape where each of the vertices, each of the corners lies on the circle. So basically ignoring the line from D to F. Now, another circle theory is opposite angles in a cyclic quad add up to 180. So this angle here, this angle BDE is 110. So this angle over here must be 70 degrees. this bit in red being opposite angles in a cyclic quadrilateral total 180 degrees. And then finally, we can now conclude that EF must be parallel to ABC because of the alternate angle theory. Okay, that the angle going from C to B to F to E. So looking at that sort of Z shape there, going C, B, F, E, this angle here being equal to this, that must therefore be parallel. Okay, so angle CBF equals angle EFB. Alternative angles are equal. 16a, write down the value of x that must be excluded from any domain of G. Now, you cannot divide by 0. You go and try and divide anything by 0 on your calculator, you see that you get an error message. So how could we make this denominator 0? Well, x would have to be minus 4. Now, for part B, read these right to left. Okay, we're going to put 2.6 as our input into the f function and get some output, then take that output and pop it into the g function. So first of all, we're going to put 2.6 into the f function. So popping 2.6 into this, 5 lots of 2.6, take away 7 equals 6. So we then take that 6 and pop that into the g function. 6 lots of 5 over 6 plus 4, giving us 30 over 10, which is 3. Part C, solve fg of x equaling 2. So we're going to put the g function into the f function. Okay, again, we're really reading it right to left. So the g function goes into the f function. So this g function pops into here. So it's going to be 5 lots of 5x over x plus 4. Okay, so that's going in here. Then taking away the 7. And that's got to equal 2. Okay, so g function into f function. So that's constructing an equation that we need to solve. So first of all, I've just multiplied by 5. So 5 lots of 5x over x plus 4. And I've also added 7 to both sides. So 25x over x plus 4 equals 9. Multiply both sides by x plus 4. Gives me this. And multiply out the claw. Gives me 25x equaling 9x plus 36. Take away 9x from both sides. 16x equals 36. Divide by 16. I get 2.25. Part D. Now we're being asked to work out the inverse function for g. So we need to change the subject for the g function. So we choose to let y equal 5x over x plus 4, and we're just going to go through the algebraic process to change the subject. So we want to go from y equaling something to x equaling something. So start off by undoing the dividing by x plus 4, so multiply both sides by x plus 4. So just processing that claw, I get xy plus 4y equaling 5x. Now I want to get all my x's onto one side and all my y's onto the other, and anything not including x onto the other. So all my x terms onto one side, all my terms not including x onto the other. So I'm going to choose to take away xy from both sides. That then leaves me with all the terms including x on the right and all the terms not including x on the left. Now this is then the clever bit. Because I've got all my terms including x on one side, I can factorise the right-hand side. So for the first time, I've now got just x being isolated. It's only cropping up once in the equation. So here it's twice, 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 and twice to start with. Now once I've got here, I'm nearly there. So just to isolate x on its own, I can now just divide by the bracket. So x is equaling 4y over 5 minus y. Now remember, y is just something I artificially introduced to help me change the subject. So my final answer, I'm just going to replace the y's with x. So my inverse function for g is going to be 4x over 5 minus x. 17 part A. Now the biggest problem here is realizing what angle they're asking for. We're being asked to work out the size of angle between CF and the base. So you've just got to visualize the two-dimensional shape as you go directly down from C. So we're creating the two-dimensional triangle CFH, and we want the angle X. So I've just isolated this triangle over here. Always just go and hook out the appropriate 2D shapes and use that as you're working. So here we go, C to F to H. My goal is to work out the angle X. Now, what length do I know to start with? Well, I know C to H is 10, but I don't know any other sides. Now, I can work out the length F to H if I just think about looking down on the square base. Okay, looking at the square base, going from F to E to H. F to E is 12, and E to H is 12, and obviously the angle FEH is a right angle because it's a square. So I can work out the length from F to H by doing a positive Pythagoras. FH squared is 12 squared plus 12 squared. So FH is the square root of 288. And I'm just going to leave it as the square root of 288. That's exact and quick to put into my calculator. So now that I know two sides of the triangle, I can work out the angle X using SOHCAHTOA. So that side is opposite, this side is adjacent, so I'm going to be using tan. So tan X is my opposite side of 10 over my adjacent side of root 288. So inverse tan both sides. X is going to be inverse tan 10 over root 288, which is 30.508, which to one decimal place is 30.5. Part B, I'm being asked to work out the length from B to E. So I'm going to hook out the right-angled triangle B to G to E, which I've done here, B to G to E, and I'm trying to work out the length B to E. Now I know the length from G to E because that's just the diagonal on the square at the bottom. So the length G to E is the same as the length from F to H, which I've used in part A. So that's root 288. So my goal is to work out the length from B to G. Now I've just hooked out the trapezium over here to help me do this. Okay, so this is my BGHC. So it's just hooking out that sort of the back of that shape, if you like, B to G to H to C. So I know B to C is 15. I know C to H is 10. I know G to H is 12. And obviously going from here, what I've called I, from I to C will also be 12. So I can work out this little length from B to I by doing a taking away Pythagoras, because I've got this little right-angled triangle here, and 15 is the hypotenuse. I'm working out one of the shorter sides. So b to I squared equals 15 squared take away 12 squared. So b to I equals 9. Therefore, the length from all the way from B to G is going to be 9 plus 10, which is 19. Now, once I know B to G is 19, I can work out B to E by doing a positive Pythagoras. So B to E squared equals 19 squared plus root 288 squared, which equals 649. Square root that, I get 25.475, which is 25.5 to one decimal place. Question 18. So I think the first thing to look at is to remember how an arithmetic series or sequence works, okay? So the first term we call A, then to get the second term we add on some common difference, we add on a number, so that's A plus D, then we'll add on that number again, so that would be A plus 2D, then the next one we'll add on another D, so that would be A plus 3D. So the first term is when n is 1, that's position 1, the second term is position 2 when n is 2, and so on. So you can see there's this difference of 1 between the position and the number of Ds. So for the 19th term, for example, that's going to be when n is 19, D will be 18. So A plus 18D is going to be 7.8. I'm calling that equation 1. And similarly for the 6th term, that's when n is 6, so D will be 5. So A plus 5D equals 39. So I've now got a simultaneous equation, two equations, two unknowns. So if I do 1 take away 2, A take away A is nothing, 18D take away 5D is 13D, 7.8 take away 39 is minus 31.2. Divide both sides by 13, I get D being minus 2.4. Substituting that back into either equation, I've substituted it into equation 1. So I now know that D is minus 2.4. I can work out that A is 51. So the first term was 51. My common difference, D, is minus 2.4. Now I'm being asked to work out the sum of the first 25 terms in this series. So I use the formula provided at the front of the paper here. So the sum of the first 25 terms, because n is 25, is going to be 25 over 2, n over 2. Two lots of my first term, two lots of A, so that's two lots of 51. Then n minus 1 is going to be 25 minus 1. And my common difference, D, we've worked out to be minus 2.4. Pop all of that into your calculator. You get the sum of the first 25 terms being 555. Question 19. So the first thing to do is to work out the lower bound and the upper bound for each of these lengths. Now, I think the easiest way to do these is just to draw a number line to help you gather your thoughts. So AD is 8.3 correct to one decimal place. So draw a number line, put 8.3 in the middle, and then go up or down one decimal place. So my goalposts are 8.2 and 8.4. Now, what range of values will round to 8.3? Well, it's going to be all the way up from halfway between 8.2 and 8.3, which is 8.25, all the way up to halfway between 8.3 and 8.4, which is 8.35. So this range of values here all round to 8.3. So our lower bound is 8.25. Our upper bound is 8.35. And just keep the symmetry. Don't worry about the fact that actually 8.35 would round to 8.4. What this should be is 8.349 recurring, but that's effectively 8.35. We want to maintain the symmetry. So don't be tempted to just put in something slightly smaller than 8.35. So just repeat that for all four lengths to get your lower bounds and your upper bounds. Now we're being asked to work out the upper bound, so the maximum area of the shaded region. So to make the shaded region as big as possible, you'd want the outer rectangle to be as big as possible, so the upper bound of ADCB, but this white rectangle to be as small as possible, so the lower bound of EHGF. Okay, to make the shaded region as big as possible, you want the outer one to be as big as possible, the inner one, the white bit, to be as small as possible. That would maximize the shaded area. So how do we get the upper bound of the area going from of the big rectangle ADCB? We want to maximize the base, we want to maximize the height. So it's going to be the upper bound of AD, which is 8.35, and the upper bound of DC, the 7.25, and then we want the lower bounds for the white rectangle. So that's going to be the lower bound for EH, which is 6.15, and the lower bound for HG, which is 5.25. So popping all of that into our calculator, we get 28.25. Question 20. Now, with this transformation of graph questions, you just really need to learn that anything inside the function, inside the bracket, affects the x values and does what's the opposite to what you'd expect. And anything outside the function affects the y values and does exactly what you would expect. So with this first one, this minus 6 is outside the bracket, it's outside the function, so it's going to take away 6 from the y coordinate. So taking away 6 from the 4, we get minus 3 minus 2. Whereas with part 2, this is inside the function, so affects the x coordinates, but does the opposite to what you would expect. So rather than timesing by 2, you're dividing by 2, or in other words, you're multiplying by a half. So you're going to be halving the x value. Half of minus 3 is minus 1.5. So minus 1.54. Question 21. Well, I thought this was quite tricky, particularly as there seems to be no way of solving it until you realize later on that one of the powers becomes the power of 0, which does allow you to solve it. Anyway, how would we go about this? We really want to break everything down to have the same base numbers being either 2 or 3. Okay, so this term's all right already. That's 2 to the power of something. This is 3 to the power of something. We need to convert these 18s and the 12s to being 2s and 3s. So you need to appreciate that 18 is 2 times 3 squared. and 12 is 3 times 2 squared. So start off by replacing the 18 with 2 times 3 squared and the 12 with 3 times 2 squared. So that's what I've done here, and that's equaling m, which is equaling 2. So now just go and apply, get rid of the brackets basically. So it's going to be 2 to the power of 4n and 3 squared to the power of 4n. Now remember, when you've got a power inside and outside the bracket, you multiply them. So this is going to become 3 to the power of 8n. So 2 to the 4n, 3 to the 8n, which I've done here. And similarly, applying the, getting rid of the brackets here, we're going to have 3 squared and 2 squared, which is 2 to the power of 4. Now, let's just go and gather up all our powers. So remember, when you multiply, you add the powers. When you divide, you subtract the powers. So this times this, we're going to add the powers. So we've got 4n plus 3n squared minus 18n. And then because we're then dividing by 2 to the power of 4, that's going to be subtracting 4. So that's the key bit, understanding this bit that I've highlighted in orange. We're adding these but subtracting this, giving us 2 to the power of all of this. And similarly with the power with the 3's, we're adding the 8n to the 2 minus 8n, and we're subtracting the 2. And this is the bit I was referring to earlier on. That rather conveniently cancels down to being nothing. 8n minus 8n is 0, 2 minus 2 is 0, and 3 to the power of 0, anything to the power of 0 is 1. So we're just multiplying by 1, so all of this bit here effectively disappears, just leaving us with 2 to the power of 1 equaling 2 to the power of all of this. Now if you gather all of this up, okay, we gather all of this up, so we've got 3n squared minus 14n minus 4 equaling 1. Take away 1 from both sides, we're left with 3n squared minus 14n minusing 5 equaling 0, and that's the quadratic that we can solve. So I've solved that over here. Okay, so what two magic numbers multiply to be 3 times minus 5, which is minus 15, but add to be minus 14? That's 1 and minus 15. So split this minus 14n into being 1n and minus 15n. Doesn't matter which way around. So I've just replaced the minus 14n with minus 15n plus n. Fully factorized terms 1 and 2 gives me 3n and minus 5. And repeat fully factorized terms 3 and 4. Well, that's just one lot of n minus 5. And then our pair of brackets are the two components that aren't inside a bracket. That's the 3n plus 1 and the repeated bracket, the n minus 5. Which values of n make each of these brackets 0 in turn? Well, this bracket will be 0 when n is minus a third, and this bracket when n equals 5. Question 22. Now, there's a lot going on here. I thought this was a tricky question. So I think with all problem-solving questions like this, just do whatever you can. Just pick up the method marks and just hopefully the penny will drop as you go through. So just really work out what you can. Now, we're being asked to work out the area of this shaded region. So let's just break that down into a rectangle and a triangle. So our end goal is going to be to work out the area of both of those two, the rectangle and the triangle, and add them together. So what can we work out? So let's just go through the order I did it. The first thing I've done, I've worked out this sort of interior angle of the octagon. Okay, now it's a regular octagon, it's a regular 8-sided shape. So how do you work out that? An 8-sided shape would comprise 6 triangles. So that's 180 times 6, divide by 8. So each of those triangles is going to be 135. Okay, so the total of the interior angles, because it would be 6 triangles, is 180 times 6. Spreading that equally over the 8 angles, you're dividing by 8 to give you 135. Second thing I've done is to work out angle CDA. Now obviously CDE is another one of the internal angles, which is 135. Obviously ADE is 90 degrees. So CDA must be 45 degrees. So that's the second thing I've done. I've then gone back to this little triangle ABC. Now the length A to B and B to C are obviously 10. So this is an isosceles triangle. We know that angle there ABC is one of our 135s. So therefore, these two angles here must be the rest to make it up to 180. So 180, take away 135 divided by 2, being 22.5. And again, just really trying to fill in as much information as I can, picking up method marks as I go. Now that I know that this angle is 22.5, this angle BCA, and BCD is one of these 135s, this angle here, ACD, must be 135, the internal angle, take away the 22.5, which is 112.5. Right, now that I've got all those angles out of the way, I'm now going to try and work out the length AD, because obviously once I know AD, I can work out the area of this rectangle just being base times height. So how to work out AD? Well, first of all, I'm going to need to know what AC is, and I can work out AC by focusing on the triangle ABC, where I've got side, angle, side, so I can use cosine rule. So just using the a squared equals b squared plus c squared cosine rule, just for taken from the formulae at the front of the paper, ac squared equals 10 squared plus 10 squared minus 2 lots of 10, 10 cos x, so cos 135. And putting that all into the calculator, I get AC being 18.47759. Now, once I know AC, I know one length here, I've now got a pair inside this triangle ACD. So I can now use the sine rule to work out what the length AD is. All right, now that I know AC, I know that length, I know that angle, I know that angle, so I can use the sine rule because I've got the pair. So AD over sine 112.5 equals my 18.47759, my AC over sin 45, and that gives me AD being 24.142. So I now know the length AD. Now obviously once I know AD, I can now work out the area of the rectangle being base times height. So base of 24.142 times the height of 10 gives me the area of the rectangle ADEH being 241.42. Now, my eighth step, I'm going to work out the area of triangle ACD using the area of triangle rule, half AB sin C, and I'm doing it from the point of view of this angle 45. So my two accompanying sides, so my A and my B, are the AD length of 24.142 and my CD length of 10, and obviously the angle C is 45 degrees. So my half AB sin C gives me an area of the triangle of 85.35. So I know the area of the triangle, I know the area of the rectangle, these are the areas 2 and 1. Add these together, I get a total area for the shaded area of 326.7 ... So to the nearest centimetre, that's 327 centimetres squared. Question 23 to finish. So the total number of beads I've got are all the blues, all the whites and all the oranges. So that's 3 plus 4 plus x, which is x plus 7. So that's going to be my starting total. Now, I've been asked to work out the probability, well, I've been told that the probability that Jean takes two of the same colour is 3/8. So that's really my starting point. So the probability of blue blue or white white or orange orange equals 3/8. So what's the probability of a blue followed by another blue? Well, it starts off with my first pick of 3 out of x plus 7. But then if a blue's gone, for my second pick, the chances of getting a blue is going to be 2. But we're now 1 bead less, so it's going to be over x plus 6. So the probability of blue blue is this times this. Similarly, probability of white white. Well, there's 4 to start with. So there's 4 to choose from the first pick, 3 to choose from the second pick. And again, the denominator starting off at x plus 7, but once 1 bead's gone for the second pick, the denominator is x plus 6. And similarly, the probability of orange orange, x out of x plus 7 for the first pick, and then x minus 1 over x plus 6 for the second pick. So really that's the tricky bit, I think, all right, just constructing an equation. So x is our only unknown, so at the end of the day we've just got to solve this, and that will be our final answer. So, processing the left-hand side, we've got the common denominator of x plus 7 times x plus 6. So then the numerator, 3 times 2 is 6, 4 times 3 is 12, and x times x minus 1 is obviously x times x minus 1. So then simplifying the left-hand side, 6 to 12 is 18, x times x is x squared, x times minus 1 is minus x. So then what I've also done at the same time, I've then choosing to multiply top and bottom by x plus 7, 8x plus 6, giving me this line here. Now going from this line to this line, I've done two things. To undo this dividing by 8, I've multiplied both sides by 8. And on the left-hand side, I'm just writing this in the normal order. So my x squared, then my minus x, then my plus 18. And I've taken the opportunity to multiply out this pair of brackets. So x times x times 6, 7 times x, 7 times 6. Gathering the x's in the middle, I get x squared plus 13x plus 42. I'm now just going to multiply the left-hand side by 8 and the right-hand side by 3, giving me this. Then I've gathered it all up onto the left, giving me this quadratic equation here, which I need to solve. So solving this quadratic, what two magic numbers multiply to be 5 times 18, which is 90, but add to be minus 47. That's minus 2 and minus 45. So then my next line of workings, I'm going to go from 3 terms to 4 terms. So I'm breaking down my minus 47x into minus 2x and minus 45x. Doesn't matter which way around, I've put the minus 45x first. So that's that line there, going from 3 terms to 4. Next step, fully factorised terms 1 and 2, giving me 5x, x minus 9, and fully factorised terms 3 and 4, giving me minus 2, x minus 9, and I get this repeated bracket. So my final pair of brackets are these two components that aren't in a bracket, the 5x minus 2, and my repeated bracket being x minus 9. Now my two solutions for this are minus 2/5, that's the value of x that makes this first bracket 0, or x being 9. Now obviously x has got to, which is a number of orange beads, has got to be a whole number and positive, so we reject the minus 2/5 solution. So x, the number of orange beads, is 9. So our total number of beads is 3 add 4 add 9, so 7 plus 9, which is 16.